वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। Now today we will start with the haloalkane and haloarenes. So in last video of the haloalkane and haloarenes we have covered till the preparation of haloalkanes. Today we will start with the preparation of haloarenes. So preparation of haloarenes. So preparation of haloarenes can be done with a two way. One is known as side chain halogenation, side chain halogenation, and other is nuclear halogenation. Nuclear halogenation. So let's start with the side chain halogenation. So in side chain halogenation, now the first one is a reaction of toluene with halogen. Basically chlorination, we can say, with chlorine in presence of sunlight. It gives you side chain halogenation. How? Have a look here. I'm just giving the example of the toluene. So this is toluene. Now when the toluene reacts with the chlorine in presence of sunlight, it will give you can write it toluene just like this, CHH, H over here. So chlorine is ClCl, so one HCl is out from here and it will form benzyl chloride. This is your CH2Cl plus HCl. This is benzyl chloride. Or we can also say is benzyl chloride as phenyl 1-chlorobenzene or phenyl chlorobenzene. This is also known as phenyl chlorobenzene. Now have a look. There's some more reaction. If it further undergoes halogenation, suppose this benzyl chloride further undergoes halogenation, so what will be the product? So if the further undergoes halogenation in presence of sunlight, excess of chlorine in presence of sunlight, so again HCl is out from here and it will give you dichlorobenzene, or this is like this. So this is the benzyl dichloride. No? Simply we say the benzyl dichloride. So this is your benzyl dichloride. Now when the benzyl dichloride react with chlorine in presence of sunlight, so it will give you benzotrichloride. So this is a benzotrichloride. Now we can also say is a 1,1,1 trichloro 1-phenyl methane. So this is also called as 1,1. This is phenyl chloromethane. This is not the benzene over here. This is the phenyl chloromethane. We can say methane. Now have a look here. So now this is what? Benzotrichloride. So 1,1,1, we say 1,1,1 trichloro chloro, and the phenyl is the same. So 1 phenyl, 1 phenyl, 1 trichloromethane. Methane. So this is the IPC name of the benzo trichloride. So this can give the different product. Now I'm just giving you some question how you will solve this. Suppose we have CH2 CH3, and it will undergo chlorination in presence of sunlight. So what do you think, what will be the product? And it forms X. This further on reaction with the chlorine and the sunlight, it will give you the Y. You have to find out the X and Y. So how we just get the X and Y? So have a look here. So it have the 2 hydrogen. So this will react. This will undergoes reaction. So HCl will out from here, and it will form a product just like this. This is your Cl over here, and this is CH3 and H. HCl is the byproduct. Further it will undergo chlorination. Then this hydrogen and this chlorine will get react, and it will form like this. So this is the way this is the answer of the questions which I have given you. Now we'll just move to the nuclear halogenation first, then from diagenomic salt. So nuclear halogenation is what? Second one is the nuclear halogenation. Nuclear halogenation. For the nuclear halogenation, what is the required thing? So for the nuclear halogenation, we need benzene. How you form the chlorobenzene? We are forming the chlorobenzene. So the benzene will react with FeCl3 with the chlorine as a catalyst of the FeCl3. So FeCl3 is what? FeCl3 is a catalyst. So benzene plus chlorine in presence of anhydrous FeCl3, so it will form HCl is out from here. Now it will form chlorobenzene plus HCl. So if the bromination is there, then bromobenzene, just like this. Now the next method of preparation is we can get it from benzene diazonium salt. So from benzene diazonium salt. So there is some name reaction. Let's start with the name reaction. Now one is the Gattermann reaction. So what's about the Gattermann reaction? So Gattermann reaction states that when benzene diagenomic chloride. First, how just get the benzene diagenomic chloride? And what is the benzene diagenomic chloride? So benzene diagenomic chloride, benzene having N2 plus Cl minus is the benzene diagenomic chloride. This is your benzene diazonium chloride. Now how it will form? So when aniline react with HONO or nitrous, that's a nitrous acid, or NaNO2 plus HCl, then it will form benzene diazonium chloride. This is your benzene diazonium chloride. Now, so this is your aniline. So you can prepare benzene diazonium chloride from aniline. So Gattermann reaction is what? This is the name reaction. And Gattermann reaction states that when benzene diazonium chloride reacts with copper and HCl. If it react with the copper NCl, then it will form chlorobenzene, and nitrogen is out from here, so nitrogen is removed. Now, if it react with copper with HCl, copper with HBr, then what will happen? So if it form copper with HBr, then wait a second. Suppose we just take the benzene diazonium chloride, and in presence of copper and HBr, so again the nitrogen is out from here, nitrogen is out, and bromobenzene is formed. Bromobenzene is formed plus nitrogen. This is the Gattermann reaction. Now there is one more. There is a Sandmeyer reaction. Sandmeyer reaction is what is the Sandmeyer reaction? Just wait a second. Sandmeyer reaction. Sandmeyer reaction is what? Sandmeyer reaction we can say. So when you take a benzene diazonium chloride, this is your benzene diazonium chloride, and in presence of CuCl and HCl, then again nitrogen is out from there, and it forms chlorobenzene plus nitrogen as a byproduct. So this is one thing. Now if we take like CuBr and HBr, then it will form bromobenzene plus nitrogen is out. One more thing, then when it react with the aqueous potassium iodide, then it will form iodobenzene as well. So it will form iodobenzene. But this is not the Sandmeyer reaction. These two are considered the Sandmeyer reaction. This is the method of preparation of iodobenzene, you can say. Now, is there any other way to form the halobenzene? So there is one, is known the Balch-Simon reaction. Balch-Simon, SCHIEMANN reaction. This is also the name reaction. So what happens? This is basically the method of preparation of fluorobenzene. So again, we will start. We will take the aniline. Aniline is over here. Aniline, and we react it with NaNO2, and we will take some more. That is the fluoroboric acid, HbF4, and third the condition is 273 to 278 Kelvin temperature. So what it will form? It will form benzene diazonium tetrafluoroborate. So this is your N plus triple bond NBF4 minus. This is known as benzene diazonium tetrafluoroborate. Now, when the benzene diazonium tetrafluoroborate is heated, when it is heated, then it will form fluorobenzene. This is fluorobenzene plus nitrogen plus BF3 as a byproduct. So these are formed as a byproduct. So this is on the Balch-Simon reaction. So this is the method of preparation of fluorobenzene. Now next one, we have one more name reaction. That's another Huns-Diecker reaction. Huns-Diecker reaction. This was also the method of preparation of haloalkanes. Now here Huns-Diecker Huns-Diecker reaction. So what's about the Huns-Diecker reaction? So when silver salt of fatty acid, what do you take? When silver salt of fatty acid, like we just take C double bond OOAG. This is the silver benzoate. Silver benzoate when react with a bromine in presence of CCl4 reflux, then what will happen? So AgBr is out from here, CO2 is out from here, and it will form what it forms, that is the bromobenzene over here. So this is the bromobenzene plus CO2 plus AgBr as a byproduct. Now, so there is one more method of preparation, that is also the name reaction, but this is the commercial method of preparation on the large scale. So how this is on the racing process, RASCHIZ, racing process. So what the racing process is? So when you take the benzene and HCl undergoes oxidation in presence of CuCl as a catalyst, and it is heated, then it will form chlorobenzene. So this is the balanced equation I am writing over here. So this is chlorobenzene and H2 as a byproduct. So this is the method of preparation of haloalkanes. Now I'm just going to make a flow chart for this. So flow chart is just like this. This is the halobenzene. Now the first one, what we did, we have started with a nuclear side chain halogenation. So in side chain halogenation we have taken the toluene. So just remember that when the toluene reacts with undergoes chlorination in presence of H or the sunlight. H or sunlight is the same. Sunlight. Then it forms benzyl chloride. Now for the benzyl dichloride and for the benzo trichloride. So you should keep in mind. Now again, when the benzene undergoes chlorination in presence of anhydrous FeCl3 as a catalyst, then it will form chlorobenzene. Now the next one we have benzene diazoam chloride. When the benzene diazoam chloride reacts with CuCl, Cu or HCl, or Cu and HBr, it will form corresponding chlorobenzene or bromobenzene. Nah? So you should keep in. So now this is known as Gattermann reaction. This is known as Gattermann reaction. Gattermann now the next one we have the reaction that is the Sandmeyer reaction. Again we just take the benzene diazoam chloride with the CuCl and HCl, or CuBr and HBr. This is known as Sandmeyer reaction. Sandmeyer reaction. So now we'll just move towards the next one. Next one we have Ball-Simon reaction, in which we take this is the fluorination. This is the benzene diazonium tetrafluoroborate. So this is the benzene diazonium tetrafluoroborate. And when it is heated, then it forms fluorobenzene. Now this is on the Ball-Simon reaction. We can say this is the Ball-Simon reaction. So this is BaS LZ Balch SCHIEMANN Bal-Simon reaction. So this is the next one. Now we have benzene diazoxide chloride, have Bal-Simon, Gattermann, Sandmeyer. Then one more, the Huns-Diecker reaction. So what the Huns-Diecker reaction? So we just take the silver salt of aromatic acid. So COOAG, this silver benzoate, and it undergoes bromination in presence of CCl4 reflux. Then this is known as Huns-Diecker reaction. HUNSDIECKER, Huns-Diecker reaction. Now again we have one more, that is the Raschig process. So Raschig process is when we take the benzene and HCl under oxidation. So this is known as Raschig process. This is the commercial method of preparation of halobenzene, the chlorobenzene. So this is RACHIZ, Raschig process. So these are how many reactions we have. So we have, wait a second, how many reactions we have? We have 1, 2, 3, 4, 5, 6 and 7. So this is the 7 reactions we have. So regarding the method of preparation of haloarenes. So in this video we have covered the method of preparation of haloarenes. So in next video we will study about the chemical and physical properties of haloalkane haloarenes. So till then, goodbye, take care.